our lovely astronomy club. And Holy Night. Music by Adolphe Charles Adam and words by John Sullivan Dwight. English folk song arranged by Kathy Peck. And now we come to It Came Upon a Midnight Clear. Manger with Kilpatrick Murray, arranged by Kathy Peck. Oh, okay. An arrangement by Kathy Peck and John Hopkins. Okay. This one is right. more?
It is. We are on time. Lovely. Thank you very much, Anna and Kim. That's such a wonderful duet.
Thank
Uh,
you so much for having us.
Yes.
Hi, Mom.
Thank you, Risa. I unfortunately we are having a problem with the sound here, so
Oh,
we had to miss out on it in the auditorium. But thank you both very much. I'm hoping maybe I'll catch it on the replay.
I hope so.
you missed a great performance, Barbara.
Yeah, I know. We're all really, really sorry. Um, anyway, though, welcome to everybody online and everybody that is here in the auditorium to the December meeting of Orange County Astronomers. We're coming to the end of 2024 and the start of 2025, and we still have an election going on. So if any of you have not voted yet, you still have until the January meeting to get your votes in. Can you hear me?
Barbara, by the way, are the lights off in the auditorium? I can only see a blank screen. I don't know if others can see you.
I'm not sure what
okay.
happened with the camera.
Okay.
Okay.
Sorry,
Sorry.
we are good. Please continue.
Okay. Anyway, get your votes in, and remember that the deadline for voting is the day of the January meeting. And I'm sorry, I forgot what the date is off the top of my head. Anyway, I know we've got a really great program tonight, and you would much rather hear from those people than you would hear from me. So I will gracefully turn this over to our announcement specialist, Kyle Graham. Welcome, Kyle.
Hello. All right. So first off, welcome new members. If you're attending in person, your name badge will be up on the whiteboard either this month or next month. If you're attending online, after a couple months, those will be mailed to you. Coffee notes and more are available for purchase for those in person up by the library entrance. The next ANSYS Star Party will be on December 28th. Astrophysics will meet on December 20th. Astroimaging on January 3rd. And the beginners class January 6th. The next board meeting is January 26th. If you're interested in the club's Adopt Scope program, you can find more information about it on the website, including sample inventory, sample adoption agreement, and more information about the program, and if that might be something that would be interesting to you. Martin Christensen is the Outreach Events Program Coordinator. Please contact him if you are interested in volunteering at any of these events coming up in January, as we need volunteers for these outreach events. They're fun events to get to show lots of students the night sky. That's something you would enjoy. Contact him to sign up. If you have any items that you think would be interesting to have go in the series Astronomer, please send those items of interest to Dave Fisher and he will review those. Once again, just a reminder that the Serious Astronomer newsletter is always available online. Everyone does receive a printed copy, but if you would like to opt out of receiving the printed copy, please let Charlie know. Reminders for the ANSA site to lock up the ANSA house if you're the last one there. Ensure all the windows are closed to keep critters out, and to close the gate to the site if you're the last one to leave. And also, please remember to keep weeds clear to help lower fire risk on the property. Reminder about the elections. You should have all received an email already to allow you to vote online. If you're having issues with that, please contact John Hoot, or you can send your ballot in via mail or drop it at the January meeting. Here are the candidates for the upcoming year. Even though all the races are uncontested, we do appreciate you voting as a vote of confidence in leadership. The next general meeting will be January 10th. That is when all ballots for the election are due. And I'll turn it over to John Garrett for the What's Up presentation. Thank you.
Yeah, just give me a moment here to get the presentation displayed. And let's see, get the moment. And screen sharing next. Okay. Okay, is that am I on? Do you see the what's up? Everyone, okay, I'm
All
getting the
good.
thumbs up.
All good,
Thank you.
John.
Thank you. Again, thank you for inviting me out here to do the What's Up. I know I'm welcome to drive out here for any meeting that you have, but when you invite me to do the What's Up, it kind of guarantees that I get out here, and it's really nice to be able to do that. And so I'm going to share a bit of what's in the sky, and I'm trying to hit the advance button, and it's not working. So let me figure out what I've done wrong here. Okay, there it is. First of all, this is just a little information up front. I think all the pictures I took in this What's Up are pictures I've taken with one of these telescopes or one of these lenses. So if I'm ever saying a 3-inch, it's my 3-inch refractor that you see in that picture. If it's an 8-inch, it's the 8-inch that you see. Otherwise, most of my photos are taken with a 24 millimeter, a 14 millimeter, or an 85 millimeter lens. And anyway, what you might notice that time of year, again, where you start to see these great optical effects because of the weather. This was from 2 nights ago. First halo around the moon that I've seen. I think that's Jupiter in the far upper left of the picture. Last year, this time of year, I had seen one of the most amazing combination displays of parhelia. That is these effects caused by sunlight through ice crystals. And so here it is where you have like, I think 7 different unique objects all in this one picture. And then very recently, actually, when I saw this, I thought, okay, I've seen it all. There's nothing new in the world of parhelia optical effects for me to see. And then very recently, I actually saw something new one more time. And so here I am out on a hike. Sun is visible. I'm trying to block the sun with my fist, but I'm using my cell phone. And you can see I've got a ring around the sun, a secondary ring at the top, and some bright sundogs left and right, those splotches of color. But you also see that day was amazing. There was a parhelic arc that is a circle all the way around the sky. And it was the only time I've ever seen that. And I actually think there's a painting painted in the late 1500s that actually depicts one of these being sighted in Europe. And I should have hunted down that painting, but I only thought of it most recently. But anyway, so here's that sundog and following the parhelic arc, and it doesn't look perfectly round because my cell phone camera distorts the picture. And then there's a second splotch that is like a sundog, but it occurs 180 degrees radius, a circular radius away from the sun. And I've only seen one of those once, and I didn't think it was a real thing when I saw it, but it turns out that it's a real thing. And so it's like a sundog, but it occurs in the direction away from the sun. And I've never seen such a good example of one before. And anyway, here I am showing pictures of following this arc all the way around. And here's my panorama shot of it, where the sun is the only thing missing from this. But that day we had a perfect arc all the way around the sky. So as it gets cold and we get more ice in the atmosphere, we're going to see a lot more of these events. And so I invite you to walk out during the daytime looking for these things, as well as doing observing at night. Another daytime observing event that only can take place during the day is observing the sun. And I've consistently noticed that it's always having sunspots right now. So we're near a solar maximum. And I've found that almost every day I go out and take a look, there's sunspots. So I recommend, if you have a safely filtered telescope, to get a look at the sun. we have some meteor showers. One is going on now. The peak, I think, was this morning, but its duration is going to be to the 20th. So you may see geminid meteors anytime you get out. But otherwise, this particular showing of the geminids coincides with a very bright moon, which washes out most of the meteors. And also there's the Ursids, which are a very minor meteor shower, supposedly 10 per hour. And there's a barely gibbous moon. So the moon won't be as bright if you watch for that. And then there's the quadrantids, and that's supposed to peak on the 3rd of January, and you may get up to 80 per hour. And I've never seen quadrantids before, so it's tempting to take a look. Here's the radiant of where the quadrantids should be. So if you get up in the morning sky, find Hercules, which is that purple butterfly I've drawn in the middle, and Draco off to the left. Right up there should be the radiant of the quadrantids. Here's my only geminid meteor. I don't know if you can see it, but below Orion to the right in this picture, there's a geminid meteor. And this was one that is an Ursid. I caught it the night of the Ursids, and when I traced back the direction, it looked like it was an Ursid, but I've since decided that most of my meteors pictures are probably satellites. Here's one that I thought was a meteor, and I shared plentifully with people about my meteor picture. Then I began to suspect that most of mine were satellites, and now I always overexpose, always look for other things. And if I can see a continuous line, it makes me think it's probably a satellite, not a meteor. So don't be fooled by satellites as you go out and hunt meteors. Anyway, there's plenty of planets out tonight and over the next month. And so here's a picture I took 2 weeks ago at Joshua Tree National Park, and I'm looking toward the west when I took this, and I'm using my 14 millimeter kit camera lens that came with my camera. And so there's Venus, the bright object. And right next to Venus is the constellation Capricornus, which looks uncannily like a sea goat. And Venus is going to travel through Capricornus over the month. And it'll just above it, beyond it, is the constellation Aquarius, one of those constellations that I've had trouble believing in because I can never really make out the stars of it. The brightest star that you'll see near Venus is Fomalhaut, which is the brightest star in the southern fish, Pisces austrinus. And if we go a little farther this way, this would be Saturn. Saturn sits pretty high. It doesn't look terribly bright, but it does stand out as kind of bright in the area. And the rings are very close to edge on, not completely edge on. My understanding is that in March of this year, we may get the point where the rings will actually look edge on and almost disappear. So you might want to be watching for that. And anyway, from Aquarius, we go a little higher, there's Pisces, and then right about here is Neptune. And by the way, these planets are showing up on my camera where I'm taking like I think about maybe a 30-second exposure, and they show up they show up on the picture. And by the end of the month, you should see Venus here. So those planets will be nice and evenly spaced in the sky. We go a little farther this way. Now we're swinging around and looking more toward the east, and we come to the constellation, the Aries, the Ram. And in Aries, we go a little farther, and you can see just below Aries, the Pleiades, a very recognizable star cluster. And just to the right of the Pleiades is where you'll find the planet Uranus. And then even farther down, now we're looking in the early evening, way over in the east, you'll see Jupiter right here between the horns of Taurus, the bull. And here's one more picture I threw in because the lower I photograph, the more planes I get in the picture. And one of them flew almost exactly through where Jupiter was. So I just threw that in for fun. And now if you wait longer into the night, you'll be able to see Mars. I didn't wait longer into the night. I took this picture here at another time of the year, but it also shows, but this constellation will rise after a couple hours of the evening, and it'll be followed by the constellation Leo. So we got Cancer, the crab, and Mars will be about right there. So Mars makes a nice object of contrast with the Praesepe star cluster, which is the center of the Cancer constellation. Now, if I go back to my evening looking toward the west, looking at Venus again, I went left for the pictures I showed you, but I could have gone right. And if you go right, you can follow what's left of the Milky Way that you can see this time of year. And low in the sky is the summer triangle still visible. And the constellations Aquila and Cygnus the Swan are still up pretty high to get a good decent view of objects in them this time of year. If I continue along the Milky Way, spanning toward the north, we come to the constellations Cepheus the king and Cassiopeia the queen. And then when we come a little farther, beyond Cassiopeia, still following the Milky Way, we come to Perseus. And then just beyond Perseus's foot, you should see the Pleiades again. So we've come full circle both way, swinging high to the south and then swinging high to the north, ending up facing the east both times in this little tour. There's so many star constellations that are great to look at this time of year because we've got the winter constellations rising. You don't have to wait too long, but I like to what I'm going to be looking at this month when we get a chance is Cetus the whale, because Cetus the whale peaks at its highest in the sky in the early evening and before it gets too cold. And so it's one of those things that has a few unusual things in it worth looking at. Here's a picture I took at another time, a couple years ago, and you can see Orion off to the left. Now imagine Orion in the early evening is actually on its side, and Cetus the whale then will be pretty high in the sky, just above Eridanus the river, and Cetus the whale would be right about there. And some things of interest in Cetus, like if you're just talking standing around talking about things that are interesting, is the star Mira, which is a periodic star, is in the whale. And so that will actually go from fairly bright to actually not visible to the naked eye over a 322-day period. So it's one of my goals to get some pictures of that constellation with the fading Mira star. And just sort of a trivia thing, the star named Earendel is the youngest star ever observed. There's this feature, a gravitationally lensed feature. We can't see that with amateur telescopes. You need something like the Hubble Space Telescope to see it. But there's a feature called the Sunrise Arc, which is a gravitationally lensed galaxy. And in that lensed image, there is astronomers have identified what they believe is a single star that would have been created within the first billion years of the universe's existence, so at least according to our estimates. And so you can point to that area and go, the oldest known observable star is right there, but you can't see it with amateur scopes. Over here, 40 Eridanus, the second dwarf star, second dwarf companion ever discovered. And up here, there's Pisces just above Cetus the whale, and a few galaxies there, M74, M77, and NGC 524. Most of these I have photographed from my home in Wildemar. And so here's a couple of them, M77, M74, very beautiful galaxy. And this was done with a 3-inch telescope. And then this one with my 8-inch, you can start to see a little more detail in it. And then this one is NGC 524. And then back to Cetus. Just below Cetus is Fornax the Forge. And over here toward the front of Cetus are four objects that are fairly interesting. One is one of my favorites, NGC 246, a planetary nebula, which is essentially a dying star that went through a very slow death and blew off its outer layers, and now we can see those layers being energized by the remaining white dwarf in the center. And then there's a little galaxy here. I don't know how this one would look in a telescope, but it looks like you could probably see it with an 11-inch telescope. And then there's a great globular cluster very close to a tempting galaxy up in the upper left. And so if I now move my scope, my 3-inch scope from there to there is a NGC 253, a very beautiful galaxy. And here it is with my 8-inch scope. And so anyway, Eridanus the river. And one area that I hope to look at next is just left of Fornax the Forge in this drawing is another galaxy cluster. Looks like a whole bunch of little dots on my star chart, but I hope to do a deep soaking of that area and see what shows up on a 3-inch telescope. Also a favorite, NGC 1535, which is in Eridanus the river. That's here it is. It stands out as a nice little green dot. So it's something that I'd hope to, here it is in my 8-inch. I love planetary nebula. They're just one of my favorite things to look at. And so my goal is to make them your favorite thing to look at. Anyway, so Cetus the whale. Take a deep dive with Cetus the whale this month. It's up at its highest in the early evening. You don't have to stay out late. You don't have to, endure a lot of cold. And so I highly recommend it. Thank you for your time.
Thank you very much, John. What a wonderful presentation and great images. Thank you. And I'm happy to announce that John has agreed to do more WhatsApps for us in 2025. So great things to come ahead. Now, let me go ahead and introduce our speaker for tonight, who's a professor at Michigan Technological University. He holds a PhD from the University of Pennsylvania and is a fellow of the American Physical Society. He is perhaps best known as a creator and editor for one of NASA's most popular science websites, the Astronomy Picture of the Day. And let me also tell you that he has a recent book as a bestseller titled Faster Than Light: How Your Shadow Can Do It, But You Can't, which is available on Amazon. Please join me in welcoming Dr. Robert Nemiroff. Robert.
Thank you. Okay, I will attempt to share my screen correctly to show my presentation. You might get a slight shock. Okay, still working on it. Slideshow from start. There we go.
Oh, good.
If there's a problem, please tell me because I think it's running. So, hi again, everybody. Thank you for inviting me. I'm very happy to be here. And so this is going to be the year in review, 2024 Astronomy Picture of the Day. So I am Robert J. Nemiroff. My collaborator in creating the Astronomy Picture of the Day is Jerry Bunnell. So I'm from Michigan Technological University, which is in the Upper Peninsula of Michigan, far away. And yes, we have snow on the ground, and it was snowing earlier today. Not a problem. So Jerry's from the University of Maryland. He will not be joining us today, to the best of my knowledge. Always surprised. Okay, so first of all, what is APOD? As we call it, there's no T. We don't pronounce the T because it doesn't sound right. So you can get there by typing apod.nasa.gov. We started at NASA in 1995, the old days. So it is one of NASA's most popular science websites. We currently do over 1 million page views a day. Our log files indicate that pretty much every university in the US accesses APOD every day. We have a volunteer army, people who volunteer to help us on social media and in world languages translations. And so we're at about 20 languages that are translated daily. APOD is available over most web and social media sites. So if you can name a social media site, with the exception of TikTok, we're probably there. Long story about TikTok. Anyway, so what is APOD Part 2? So we're very fortunate. I'll do a little bit of bragging. APOD received the inaugural outreach prize at the 2022 meeting of the International Astronomical Union. But what more people would be familiar with is that APOD was actually featured on Jeopardy, to our surprise. My sister called me and told me this. I didn't believe it until I saw it in reruns. But here you see the clue for $1,600. NASA's astronomy picture, they revealed that this large moon of Mars may eventually disintegrate. Scary indeed. You might see that moon during today's presentation. Anyway, it's one of these in here. Can you see my cursor? Thumbs up if you can see my cursor. Okay, good. All right. So let's jump into this. I'm this guy right here, by the way. Anyway, this is Jerry there. Long story. Okay, so okay, I'm not seeing my notes, but it doesn't matter. So this is an older image that was, so APOD's been running since 95. In 2007, we showed a rocket plume in front of Orion, and it was taken by, I'm not really good at pronouncing names, but my understanding is this person is one of the is a member of the Orange County Astronomers, and we are happy to feature several works from Orange County Astronomers over the tenure of APOD, and I can't show them all. I can't even show everybody who's done so, to my knowledge. But this is you can see there's Orion. The constellation of Orion is here. Orion's belt is here. This is the nebula. So this is Barnard's Loop. And this is a rocket plume, so it was unusual to see that. So this is not a SpaceX plume. It's United Launch Alliance back in 2007, launching Iridium satellites, if you remember what those are. Okay, so this is by Alan Smallbone, who I understand is your secretary. Is that correct? Okay. So he sent in some good images. This is called Orion's Belt Continued. This was featured. So all the images I'm going to show you, they all have a date that they were shown on APOD. So here it is on APOD. This was featured on February 11th, 2009. Some are repeats and have been featured more than once. So if you want to go see the detail and you want to go see the write-up, then so each APOD is accompanied by about a paragraph that's hyperlinked into the World Wide Web. So the idea is that each day we feature an image, and it's hopefully a topical image, usually a beautiful image, sometimes an educational image, but it is explained by a paragraph that tries to be educational. So APOD is used in many classrooms. So the day before this, we had something on Orion's belt. So here we have more about Orion's belt, but I think you can only see one belt star here, and that's here. I can name it for you. I think it's on attack, but the other ones are off. But here you can see there's other nebula. It's actually a very rich region. Besides the Horsehead Nebula here, you can see other nebula in the area, and thousands of stars. Okay. This is from Wally Pakolka. Again, I might not be pronouncing the name. So Wally's had a lot of images. We've selected for APOD. I think he's been with us since the 1990s. I think our first one was in the 1990s that we featured of his. So this is, again, it just so happens that there's the constellation of Orion is big here. But here you have Mars on the left. So Mars does not have these spikes. This is diffraction spikes from the telescope. So all point objects will show that. But here you have the buttes in Utah. So this is the Mittens, and these are iconic structures. And so no, this is actually 2014, not 20,000. Won't be running in 2014. So a really beautiful image. Now these are usually taken in two shots. At least two shots. One is a long exposure background image, and one is a foreground image. So way back in the early beginning, this might have been considered cheating because it wasn't just a single shot. But one of the reasons why we encourage these, not only because they're so beautiful and educational, is because they're a little bit like what the eye could see if the eye could really see deeply. So it's not really fake. It's just that created by consecutive shots by the same camera. It's just that one camera was tracking the sky to build up lots of stars, and one same camera just took a quick foreground shot. And then they were merged together digitally, which is easy to do these days. So these shots, we really like and were sent in a lot. Again, here's the belt of Orion. Orion comes up sideways, as you might know. Here's the Orion Nebula. Sirius, Betelgeuse, Mars. Okay, so this one is taken by Craig Bobchin, another Orange County astronomer. So this is more recent. This is 2017, and this is a SpaceX launch. This is SpaceX, and we feature these because they're just really interesting sky sights that are very unusual. How often do you go outside and look up and see something like this? This is the sun reflecting off of a rocket plume, a really unusual rocket plume. You can see the rocket is right at the head of the plume, but the plume is very detailed and sort of looks like a flying fish. So this is not something that you would see almost ever in human history, but now you can see it because there's a rocket launch, every week or so these days, not all from the US. But they're increasingly common. So this one was a SpaceX rocket plume. Okay. Okay, so now we're going to go into the year in review, but oddly enough, we're going to start in December of last year because there's a really interesting uh, event that was actually occurred a couple years before, but it was reported in December of 2023. And this was our Earth is hit by really energetic particles, and these particles create cosmic ray air showers. And these cosmic ray air showers, the particle comes in here and it hits the Earth's atmosphere, and then it creates a cascade of many particles that come down. So probably the most energetic particle yet recorded was reported on in December, only in December of last year. So one of my goals here is to show that astronomy is not just something you look up in a textbook or on Wikipedia that has static things. Astronomy is continually changing. So one of my goals is to show you that in the last year, there's been new and interesting things happening in astronomy. Astronomy and science is a frontier. It's not just a set of facts that you memorize. So this particle that came in, Amaratsu, it's been called, had about the energy of a fast pitch for a single particle in baseball, and created a wide array that was seen by Utah. So this is on the surface of the Earth. There's a lot of arrays, water tanks that see particles zip in there, and the particles it sees are usually muons, which are very interesting type particles, and they create a track of light. Cherenkov light usually is what's usually seen, and from that you can reconstruct where the particle came from. And this was a really amazingly energetic particle. And we only learned of it like a year ago. Okay, so this is a Japanese lander that landed on the moon. This is last January, so now we're actually into this year. So there's actually two landers. This one is the one that hops like a frog and unfortunately is sort of on its side now. And it was a picture was taken of it by its companion, which broke off from it, which moves like a little like a slinky, and was able to take a picture of this and beam it back down. So this shows you that we're entering a new realm of things landing on the moon. So there are now several countries that are capable of landing things on the moon, of which now Japan has joined the club. Companies are joining the club, as we'll see later on. I'll show you another picture coming up. But here, this horizontal thing is not of interest. This is a gold foil on the Slim Lander. So the Slim Lander was not designed to last through the night, but it did. But I don't think they're in contact with it anymore. So it was sort of a demonstration, and it did demonstrate that you can put small, ambitious missions on the moon. Okay. Okay. So this is right now you see a blank screen with the title. So there's going to be a video here in just a minute. Let me set up the video. The video runs for about a minute. So what you're going to see is the Parker Solar Probe. So we live in an era where there's all these spacecraft all out through our solar system. This is like a golden age of astronomy where we're sending out these probes, these robotic probes, not only around the Earth, but all across the solar system that are just getting amazing pictures. And so this is the closest thing we've ever had to the sun. The sun is is unlike, well, we see it all the time. So we see the sun every day, we hope. But the sun, when you get close to it, has an unusual wind, and the wind near the sun and the solar wind coming off the sun has a wind of particles that flow off it. And we can see this wind here on Earth. In fact, it creates aurora. But when you get near the sun, it's actually kind of different than we thought. And so the Parker Solar Probe has been orbiting the sun interior to the orbit of Mercury and getting even closer. And we'll get even closer in 2025. It keeps going in further and further. But what it does is it has a big shield that shields the sun from it. Otherwise, it would be too bright. It is, however, heating up. But so far, they're able to contain the heat up. But what it can do is it can look sideways. And when it looks sideways, it sees all kinds of cool stuff, including lots of streaks, which are energetic particles that come off the sun. So the most energetic particle that we saw a few slides ago Amaterasu was not from the sun, but the sun does emit many energetic particles. Almost all of them are absorbed by the Earth, so very few of them reach the ground of the Earth, except for the shower that emanates from that. But they're not blocked from the Parker Solar Probe. So the Parker Solar Probe, you'll see these strange lines. About halfway through the video, you're actually going to see a coronal mass ejection, the front from a coronal mass ejection, which is an explosion out of the corona on the sun that actually passed the Parker Solar Probe. And you'll see it. And I had my student who was actually working on this, adjusting the soundtrack, have the break in the sound, or the next thing of the sound right when the coronal mass ejection passes the probe. So with that, I'll run it through, and maybe I'll run it twice, we'll see. So you should be able to hear the sound. If not, then someone please signal me. So ready, set, go. You might recognize the Beethoven 7. These are background stars, but then you see particles from the sun that light up see Mars actually right there as it goes around. This is a time lapse. This isn't real time. There you go. Coronal mass ejection assay. There's Venus, very bright from inside of Mercury. There's the planet of the Milky Way galaxy. There's Earth. You can see Earth. Parker Solar Probe can see Earth. Saturn. And we can't play all of Beethoven's Seventh. So it's an exciting time when we're learning a lot about the sun. There's aspects of the sun's magnetic field and the sun's wind that we're learning about for the first time. So what we see on Earth is not what the Parker Solar Probe sees. It sees even more detailed and interesting things. I think we're just going to go to the next one from this. So I can actually see the webinar chat, and I don't see any questions from that just now. Okay, oops, I didn't mean to run that again. Okay, so back to the moon. So this is Odysseus sent off by a US company, Intuitive Machines, not the company you were thinking. Odysseus landed near the south pole of the moon and was the first time that the United States, although it was through a company, landed something on the moon since Apollo 17 in the 70s. So we're back on the moon with probes. So this didn't last very long on the moon. Here, this picture was actually not from the surface of the moon. This is about 10 minutes before it landed. And so you can see part of the lunar surface here, but it did land and it did send back data from the moon. So Intuitive Machines is one of several companies that has the ability. However, they were launched by SpaceX. So there's fewer companies that can get us there, but there's more companies who can build probes that will do interesting things once they're on the moon. As you know, it's a priority of NASA to get back to the moon and even to Mars. Okay. So a lot of what we're sent in to APOD is beautiful nebula. So not only are we in a golden age of great spacecraft across the solar system, but we're in a golden age of astrophotography. Never before have so many people had such great equipment so they can see relatively faint nebula. It used to be back, 40, 50 years, you couldn't see this except if your name was David Malin or you had a really great setup, although he did have a great setup. But now with comparatively cheap equipment, you can and digital processing, you can bring up these great things. And this is again one of these things where there's a deep sky image which brought up the Seagull Nebula, and but it's in front of the Pinnacles National Park in California, not a coincidence. And you can take consecutive pictures and put them close together. And if your eyes are good enough, you could see this. So the Seagull Nebula is oops, I didn't mean to do that. Is an emission nebula. This is mostly hydrogen gas, although there's trace amounts of other gas there. And most of the stars you see are stars in our Milky Way galaxy. Most of the stars you see at night are within 100 light years or so. Almost all the stars you see when you go out at night are within our Milky Way and are relatively close to the sun. And that's true of most of these too. Okay, let me do it on time. All right, pretty good. All right, ooh, okay. So this was sent in to us. And this is one of these images that we just sit back and say, wow, very creative. We didn't commission this. This was sent in and we just sort of said, wow, when it came in. So Dario Genova sent this in from Italy. And this is looking in the direction opposite of the sun. And we called it Shades of Night. And every 10 minutes or so, so this was presented on, we presented this on February 28th this year. You can see that it was on the far left is they're all the bands are taken about 10 minutes apart, and night is setting in as you go from left to right. So when you're on the far right, it's almost dark. But when you're on the far left, it's almost light. So here you can see the upper sky. Yeah, it should be blue, but now you're seeing some sunset colors there. So then as time goes on, the belt of Venus rises. The belt of Venus is many times kind of a pinkish orangish color and is most noticeable opposite the sun, but runs a fair bit around the sky. So it's colored this way because it's reflecting back to you some of sunset colors. So if the sunset colors are not very red or pink or orange, then the belt of Venus won't be that noticeable. But if they are, then many times the belt of Venus will be noticeable. It's called the belt of Venus because if you trace this around and you have to get back around to the sun, Venus can sometimes be found in the belt of Venus over near the sun. The next you see here is the blue band, blue hour it's called. A lot of astrophotographers like to take pictures during blue hour. Now this is the shadow of the Earth that's rising. Night, you're in the shadow of the Earth. Day, you're not in the shadow of the Earth. So the blue hour band is sort of the rising of this where it's not completely dark. So if you take astrophotography pictures in the blue hour, you usually have enough light to see the foreground. But it's getting dark enough to start seeing at least planets, certainly the moon, which can be visible during the day, in the background. So here you can see the blue band pretty well as you go from left to right. Then there's a horizon band, which usually hugs the horizon, which is much diminished due to the great amount of air that the objects their light has to go through in order to get to you. And then I had never noticed the red band, and then there's something called the 2-degree Earth shadow. So these are not always very obvious when you're taking images or when you're just looking around at sunset and trying to notice them. You have to have a pretty distinctive sunset to be able to see these things, and you have to have a lot of patience. And you have to realize that they're a little bit exaggerated here, and it takes some patience and some understanding to pick these off. But I really love this image because it had just so much, it's such a common thing. Everybody sees the sunset, but not everybody really breaks it down into such obviously interesting bands. So this is Shades of Night, and it was sent to us and really liked it. I think my voice is getting a little, just one second. Sorry, that might help. Okay, so let's go to the next one. Ooh, okay. There was a bright comet earlier in the year, in March. You might have forgotten about it because there was another comet later in the year that you might remember better. But this one was Comet Pons-Brooks, and it was a really interesting comet. It got just about bright enough to be seen with the unaided eye. So here is a very deep image that was taken by James Pierce. Here you can see the green coma, and you can see a beautifully detailed ion tail. So the solar wind pushes out ions from the nucleus of the comet, which you can't see. You can see what's called the bright coma around there, around the head of the comet. And then the ions released from the comet are pushed out by the charged solar wind. And because the solar wind is not just a uniform thing, and because the comet itself does not just emit its ions in just one uniform thing, all of these have structure. And so many times the structure is like interesting clouds. It's fascinating in its own right. And with comets, you can never predict how interesting, how deep, how faint, how long the tails will be. So there's a dust tail, which is seen in the next comet, which we will get to. But this one had primarily at this time a ion tail. Now, Comet Pons Brooks almost was really famous for something that people were hoping it would be visible during. So one of the great events of 2024 is the event that it might have been visible during, and I looked for, but did not find. I think some people did, but they needed great images. But first, before we get to that, and I think people know what the drum roll is for, 2024 was another year where we took a really good look at the very center of our galaxy. And in the very center of our galaxy, there is a 4 million solar mass black hole. And this was imaged by the Event Horizon Telescope collaboration. And that means that there's lots of, around the Earth, lots of radio telescopes around the Earth that all took data that was later coordinated into an image that was of the central black hole. But this isn't the original image. This is sort of the original image, but it has polarization lines that are not the actual lines you can see. This was done by a computer estimation based on the data. And so, but these are lines of constant polarization mapped onto the brightness. Oddly enough, this image itself has become a little bit controversial because there was a group based in Japan who said that they reanalyzed some of this brightness and they did not get the same famous picture of the central black hole. They got these bright blobs to be slightly different. So it's a bit of a controversy right now. But these lines seem to indicate that the original image of the Event Horizon Telescope collaboration wasn't far off base. But we will learn a lot more in 2025 as to what really the central images of the black hole. So you can't really see, though, the event horizon of the black hole. It's not sure exactly how big that is. What you see is gas in front of the black hole, mostly, and gas that's orbiting the black hole. So the black hole orbits like this. And there's relatively little gas between us and the event horizon, but there still is some, which is why it's not completely dark. So this is, again, something that we're learning. The Event Horizon Telescope and other collaborations are beginning to look at other galaxies, central galaxies. So we're getting the first images in recent years, and even this year, of what the central supermassive black holes in galaxies are looking like, and hoping to learn things about the accretion disks around these black holes and about even gravity itself around these supermassive black holes, all in 2024, this year. Okay, so this was the big event. So I wasn't, in totality was not visible in California. So the path of totality went through Mexico, went through Texas, went through states. I live in Michigan. It was this tiny little bit of Michigan that it went through that wasn't very popular. You won't see Michigan on a lot of the lists. So I was trying, for a while, I was going to try to go with my students to be in this very little part of Michigan, which is like a small park that would have seen totality for only, a few seconds. But I was talked out of it by my students because who knows, it could have been cloudy or we wouldn't have been ready. So actually, we did see it. We had a big contingent from my university. We went down and saw it in Southern Illinois, and it was great. We were in a parking lot of Walmart. So I don't know if people can raise their hands, but I guess in the raise your hand if you were actually traveled and were able to see the eclipse firsthand, the total eclipse firsthand. Okay, good. Now raise your hand if you saw the partial eclipse. So there's probably more of those. I can't see the audience. So yeah, this was the second of two major total eclipses across the continental United States, North America. So the first one was in 2017. And so this one was in April of this year. And so what we have are, APOD was sending in many, many images of the eclipse, and we'll have another one next. Actually, I have a video next. So this is the Bailey's beads you can see down here. And so then this is, again, one of these conglomerate images. And then as the sun left, completely covering the moon, then you can see Bailey's beads on the other side, and you can see these prominences. So one of the things that I found amazing, and this is, I've seen a couple of solar eclipses now, but it was really, no, okay, sorry, let's go back. There we go. Is that what are the color of prominences? When you see pictures of the sun, the sun is usually colored orange or yellow, and you see prominences that are colored orange and yellow. The sun is actually pretty close to white, from what we can say. And so even the yellow-orange color is sort of a myth. The sun is almost sort of a greenish, orangish white. However, during a total eclipse, what's not white are these prominences. These prominences glow in hydrogen alpha, for one thing, and they are bright pink. They're not orange. They're bright pink. They're such bright pink, you think that this is a bad Photoshop job, and whoever did this didn't understand that you shouldn't oversaturate the prominences like that. But if you were to see it for yourself, and many of you did, you would just be amazed at the color of these prominences. They are so bright pink, it's just amazing. So this is a very interesting triangular prominence that is not that unusual prominence, but it happened to be at the right place at the right time. And so it orients a lot of the images that people took of the totality. Here you can see around the edge, the corona of the sun. So when the moon completely blocks the sun, and it's a crazy coincidence that the moon is like the same angular size as the sun. Now, sometimes when the moon is slightly further away in its orbit, it can't block the entire sun, and you get an annular solar eclipse, and you can see the sun all around the moon. And sometimes when the moon is close enough to the Earth, then you get the moon completely blocking the sun. So in a few 100 million years, the moon will be too far away to create a total solar eclipse. And why is it that we just have a moon that's the same angular size as the sun? I don't know. If you were on Mars, you wouldn't have that. The Martian moons are too puny to do that. So, but there it is. So here next, we're going to go to a really cool movie. So we're sent a lot of cool stuff. So this is a total solar eclipse, the movie from Sliver to Ring, we call it. So this was taken by Ronhold Vittich. And I'm just going to run the movie and maybe talk over it. So hold on, here we go. Also with music from Mountain View, Arkansas. Not Mountain View, California. Famous German music. Now you see the moon coming in to block the sun. You can see sunspots. As was mentioned before, there are lots of spots on the sun. We're near solar maximum. This is time lapse. This takes a little over an hour for the moon to do this. But then when you hit totality, it only takes a minute. Here you can see it's called a diamond ring or belly boot. And then you can see the corona of the sun. As your eyes adapt, the corona of the sun gets really big, but not this good. This is a long exposure, and you can see a lot of the solar wind and the scent of the corona. You can be miracle of modern astrophysics. You can see the bright pink prominences. And you'll see this for a couple of minutes, depending on where you are. And then the moon moves away. The belly boot and the solar diamond ring on the other side. There's the iconic prominence there. And you miss it. If you went to the bathroom and you missed it, it's not going to repeat there. You have to go catch the next one somewhere else. So it was an amazing event. A lot of people across the United States saw it. One of the most seen events in astronomy, one of the most photographed events in human history. Actually, what slightly beats total solar eclipses or partial solar eclipses. Well, partial solar eclipses are more photographed than total eclipses because you have to be in the line of the eclipse to photograph it to get a total solar eclipse. But partial solar eclipses, you don't. But so a lot of people took pictures, but it's really bright. Actually, lunar eclipses are even more photographed because you can see them. They're not too bright, especially if it happens early in the evening. Then there's just a tremendous amount of humanity taking pictures of a lunar eclipse. But this was still one of the most photographed events because it's seen by so many places, so many people. And you know what? So many people have phones now that can just take it. You don't have to go find your single lens reflex camera. You can just point your phone on it. Humanity now, much of humanity carries around reasonably good phones. really good cameras that can take pictures. Never before in humanity has this happened. And you know what? These are scientific instruments too. They take a lot of cool data. Okay, so I go on. I just can't help myself. Okay, so little beknownst to us, later on, there was a giant sunspot group that crossed the sun called, well, AR3664, although many people didn't know or care about the name. What was this sunspots group was so good that people who had eclipse glasses, so there are many of you might have had these, particularly for a partial eclipse, the glasses you can put on that you could then see the eclipse. You could look directly at the sun, but only through those glasses, or if you had a clever contraption. So you could take out those eclipse glasses, and instead of looking at the eclipse, you could actually see the sunspot group without any help. You could just look at it. And there was such a big sunspot group that it was really cool. But it was really cool for more than one reason, because this was a really active region, and it was throwing off flares and coronal mass ejections. And these coronal mass ejections went out into the solar system, and they were connected magnetically with particularly the North Pole of the Earth, although also the South Pole. So a lot of particles came off the sun, rushed through the solar system, a few days later, hit the Earth's magnetic sphere, and caused particles to come down onto the Earth. And that caused aurora that were visible in many places, including California and Mexico, and places that don't normally see aurora. So again, this is an event where you can just go outside. It's like a partial solar eclipse or a lunar eclipse. You just go outside and you see cool stuff. And this wasn't only visible in the United States, this was visible across Europe, across Asia. A lot of places saw these amazing aurora. So we were sent in many, many images. And so here's one. So this was sent in to us from Poland. And this was just, so you could go out, it's not this bright to the eye, but you do see something very unusual to the eye. So here, the most common color you would see in aurora is green, but above it, which is usually higher up, you could see a red aurora, and you can also see rays from this aurora. And this had an interesting observatory station in the foreground, and you can see clouds, and you can see the city down below. And so this really just captured a lot. And so what we do on APOD is we post a lot of these images on a page. So we're sent a lot of good images, and we have a focus group page that we post these on that are not necessarily going to be posted on the Astronomy Picture of the Day, but we want to see how they do and how popular they are. And this one was really popular, and its popularity did carry over when we posted it on the Astronomy Picture of the Day on June 12, 2024. Let's see. So, oops. So yeah. So this is one of the images. So did anyone see this? Raise your hand if you saw any aurora from this. Okay. So here in Michigan, we could see it, and we had people going out, my students going out and seeing some of this. Though sometimes you were unlikely. You just had bad clouds. So the sun is still really active. So there's a chance that there will be more aurora. We're just passing solar maximum now, but there is still a chance there could be a great aurora event, a great sunspot region that creates aurora further as far south as California and Orange County. Okay, so another thing that happened in 2024 is one of the successes of the James Webb Space Telescope. One second, please. So there's a new farthest object spotted by James Webb. And so here it is, the orange part of this. So almost every image you can see here is a distant galaxy. So the Hubble Space Telescope is still going. We're happy about that. But the James Webb Space Telescope, which is more toward the infrared, can see deeper into the universe, is doing a great job too. So it got lots and lots of galaxies on this deep view, but it also got something that got an optical redshift. And this optical redshift found it when the universe was 1/50 of its present age, only millions of years old. And so this is that if one of the ways that astronomers calculate distances is by redshift. How far something is, the spectrum of an object is shifted toward the red end of the spectrum. And so this redshift was 14. So this galaxy has Z of 14, which is the highest record, and it was found this year. Now, there are other galaxies that are out there at redshift 10, so it didn't shatter the record, but it did push it back quite a bit. And we're very interested to find out what the early stars were. What was early star formation like? What were supernovas like in the early universe? Because there's a slight discrepancy between the supernova brightness and the expansion rate of the universe as seen very early in the universe and the expansion rate of the universe seen now. It's called the Hubble tension. So the Hubble tension is unclear what's causing it. One possibility, which I don't believe, is that the universe expanded at a much different rate in a different paradigm early in its history than later in its history. I think we're just seeing not enough objects. There's a lot of scattering that's not being, a lot of systematic error that's not being accounted for yet, but that's a very controversial opinion. A lot of people on these projects will say, oh, no, we completely accounted for that. But it's a very fascinating conundrum that we're in right here in 2024, and will continue certainly into this next year. And so here's one aspect of it, a very distant galaxy. Okay, 2024 was another great year of exoplanets. So this is not a picture of the sky. This is a cartoon. And so a lot of 5,500 exoplanets were cataloged. We passed it. There's always more and more through Kepler. And so the Neptune type planets are seen in the middle, but these are not images of these exoplanets. These are just artists' estimations for what Neptune-like exoplanets would be. And then there's Jupiter-like exoplanets on the left, and even bigger than Jupiter exoplanets on the right. And if you look closely, there's actually Jupiter here because it's kind of a joke. We don't see Jupiter. We only see Jupiter in our solar system. But there's a great red spot. This shows you these relative to Jupiter. Also intermixed in here are smaller planets, some of which are rocky-type planets. So there's been a lot of rocky-type planets in the 5,500 that have been found. So we're finding lots of exoplanets. And one of the major pushes in astronomy and astrophysics now is to find Earth-like planets and to find atmospheres around these planets and to look for things like called biomarkers. Because we want to know if life on Earth is unique or is it just a strange fluke that is not seen out in the universe. So we're looking at these planets. We're trying to find the atmospheres of these planets. Water vapor has been found. We're trying to find biomarkers that would show that these exoplanets are showing life. Right now, there's a big battle, sort of, as to what is the first way that humanity will become aware of life out in the universe. Will it be biomarkers that might be seen around exoplanets? Or will it be biosignature, I'm sorry, or will it be a technosignature seen by radio telescopes over the left shoulder of some of the other participants you're seeing that are on the panel here? So radio telescopes, particularly the VLA, but there are other radio telescopes, are looking for technological signals that might be indicative of other civilizations broadcasting stuff to us. And even the exoplanet community, even the communities are divided as to whether we will see, but I think people are pretty sure that we will eventually find evidence of extraterrestrial life, but will it be through biosignatures or technosignatures? Not well known yet. Kind of a battle between the two. Okay, so we have instruments on and around Mars. So this is a really cool image by Mars Express, which is ESA. NASA has a part of the mission. Sorry, my voice is a little parched today. So this is a really cool image. I just like this image. First of all, you can see the largest volcano in the solar system, which is the Limbus Mons. Second of all, you can see right on the edge Pavonis Mons, which is another large volcano. Then you can see Phobos, which is the doomed moon of Mars, which was the answer to the previous question about asked on Jeopardy that was cited on the astronomy picture of the day. But there's a lot about Mars we don't know. we keep looking for signs that Mars had ancient life on it. And although we know that Mars had ancient water on it and even lakes and rivers, we don't yet have a clear sign that there was ancient life. There is speculation that life originated on Mars before Earth, and maybe when it was on the surface of Mars, there was a large collision onto Mars. It just threw stuff up out into the solar system, came down on Earth, and maybe seeded life on Earth, or life originated on Earth completely separately. Currently debated. There are big features on Mars that are not really well known. So here we have Orcus Patera. It's an oblong feature. Most craters that you see here are circular features. It's somewhat debated, a topic of research, what caused Orcus Patera. So there's a lot that we don't know about Mars, even though it's one of the closer planets in the world, in the universe, in the solar system to us. Whoops, jumping around. Okay, going to the next one. How am I doing on time? Okay, so here is the comet of 2024, I believe. This is over the Lincoln Monument in Washington, D.C. So this was taken by a camera phone, and you can just see it there. There's this Abraham Lincoln here. It's over his right hand shoulder. So this is a little bit of a deception because it was actually harder to see with the eye. This is strangely a camera phone at this point image. So what you would do is you would when it was dark, you would find the camera, you would find where the camera is, and then you take a picture of that part of the sky with your phone. Most iPhones would integrate for a little while meaning like a second. Which is more than your eye, which is like a tenth of a second or less. And then it's easier to pick up on your phone than it is with your eye. But once you see it on your phone, then you know where to look in the sky. So that's how this was seen. But here you can see part of the dust tail, and you can see the coma of the comet. And it was amazing that this was a comet that was amazing, seen to the visible eye, just this part of the year. And so this was an unexpected event in October, but we've got more on this. So once it's bright enough to see with your camera and with your unaided eye, you can take a picture of it behind anything. So this is NASA's Europa Clipper going to Jupiter. It's going out there now, launched again by SpaceX. So this will be landing in many years on the surface. Won't be landing, will be orbiting Europa and looking for signs of life around Europa. Europa likely has under its ice, it has oceans. There's a lot of evidence there's oceans there. What swims in those oceans, if anything, no one knows. But it could be hard, could have life, and Europa Clipper might be able to give telltale signs of a biosignature right there. Freeman Dyson is famous for speculating that there might be frozen fish orbiting Europa. Unlikely to be seen. I'd have to pass right by Europa Clipper to be seen. But it shows you the drama that could be out there. So this is before it was launched, obviously, and here's the famous comet that we all got to see. No, many of us got to see. Okay, raise your hand if you saw the recent comet. Okay, good. Okay. Okay, so here we are. Now the name can be revealed. Here's my cat, sorry. So this is a comet Chuchinshan. Okay, so I've been practicing this. So here you go. Tsu, everybody, Tsu. The next part is Chin. The last part is Shan. So Tsu Chin Shan. Atlas. So here we're going to show you a video now of, it was noticed that it was getting really bright, and so people were very hopeful about this. And so once it started to be visible by the unaided eye, Nicolas Lefondeau created a video of what it might look like, including its tails, and it was pretty accurate. So we ran this as it was becoming visible to the unaided eye to show what its unusual tails might likely be doing. So I'm going to show that now. There is no sound with this video, so you're not missing the sound. So it should be running. Yes, it's running. So here it's starting to move. This tail is becoming longer. It's starting to move in front of the sun. This is a picture, not a picture. This is a simulation from the Earth. So now it's going to go nearly in front of the sun, and you can see the tails So now we're starting to pick it up in the evening sky here on Earth, and you can see the anti-tail, and that points toward the sun, and you can see the regular tail that's pushed away from the sun by the solar wind and from the light from the sun. So this was a pretty good prediction. So now we're going to go to the next one. Oops. So here it is to Chinshan Atlas over California. So this is one of our more popular images. This is a globular clusters of stars. And what's really cool about this is it's got two dust tails. There is in this part of the dust tail, the ion tail, but it was actually hard to see. So the thicker dust tail was not so impressed by the solar wind and by the light from the sun, so it pointed as an anti-tail toward the sun. So here you see the lighter part being pushed out away from the sun, and here you see the coma. So it's really spectacular because you could actually see with the unaided eye both. It was easiest to see the regular tail pointed away, but if you had dark enough surroundings, you could see the anti-tail. And that was just really cool to see. We don't know when things like this are going to happen. This wasn't predicted more than a year ago. Oh, go out. The eclipse. Yeah, oh yeah, we knew that was coming. We knew that was coming a long time ago, decades ago. But we didn't know such a cool comet was going to be here. So this is the second comet that reached naked eye visibility during this year, and certainly the coolest one. And I don't know if we were going to get a comet this cool. We could have one next year, but probably will be several years before we get another comet this cool. So this was one of these double images. So this was an image taken by the Webb Space Telescope, James Webb Space Telescope, but it's of a star-forming region in the Small Magellanic Clouds. So the SMC, the Small Magellanic Clouds, is a satellite galaxy to our own Milky Way galaxy, and it has star-forming regions in here, and here you see one of the star-forming regions. And these stars here are forming, and they create, from their gaseous and dusty surroundings, they push away the light and dust to create pillars that point toward the stars, the very big, bright stars. But what's cool is when I click this, you will see, this is in infrared. When I click the image, you'll see the equivalent Hubble image, which is more toward the optical. So it's true that James Webb goes in a little bit into the optical toward the red and the orange, and the Hubble is more toward the blue. So they do share a little bit of overlap. But it's really cool to go back and forth, and you can do this by going to the 2024 October 29 APOD only a couple months ago. And so here it is. So this is the Hubble image. And I can go backwards, and here's the Webb image, NGC 602, everybody. So I'm going to do this a couple times so you can just focus on something like a galaxy. This is a far background galaxy over here. Here's some of the stars in between. Here's the gas and dust. So here's, oops, I went too far. So here's Hubble. I'm not playing well here. Webb, Hubble, Webb, Hubble, Webb. And they're pretty precisely aligned. And you can see that in the infrared, you see slightly different things. You can see more dust, but you can see through some of the other dust. So this is an area where we're learning a lot about. Webb is telling us about the infrared universe, it's finding details of exoplanets, it's finding details about the early universe, and it's finding details about star formation, not only in our Milky Way galaxy, but in galaxies surrounding our Milky Way galaxy this way. Okay, so I'll go on. We're getting close to the end. So this is another on the unusual comet Tsuchinshan Atlas. So here again, you see the dust tail, the anti-tail. But here I want to call together a feature that we started noticing in APOD. There's a dark line here that, yeah, you see it once. Maybe it's an artifact of imaging. Maybe it's just you see different kinds. But actually, the reason for this dark line is not really settled right now. And it's not just this image. Many times when amateurs send in lots of images, you can see faint features that professionals don't see, because professionals see the sky through very small apertures that only do small parts of the sky. But amateurs usually can get wide parts of the sky and pick up things that faint things because they can image for long periods of time that professionals are missing. So one of the things that was unexpected is the amateurs picked up a lot of images where they had this dark line. And so the main theory, my understanding for this is, and there are people who I think are still debating this, is that there's a plane of dust that the comet travels in. The comet travels in a plane, and much of the dust, or at least a lot of this dust, is in this plane. And so when you look at this dust plane in front of the comet itself, this dust is somewhat darker than the bright background dust, and so it seems to leave a dark line across it. But this is somewhat controversial. Some people think that there's just different parts of this kind of dust tail that you can see, and they're just different aligned. And so another possibility, which is not very popular, is that there's sometimes dark plumes that come off of, relatively dark plumes that come off of the nucleus of comets. But that one's not real popular. But here, the amateurs are contributing by showing lots of images of this. This isn't just one. Lots of amateurs saw this. So exactly what's causing it is still being debated and might help us understand comet nuclei better in the future. Okay, so this one was a surprise one too. So this was a low-tech, really cool thing. So this is one of the last images I'll show you. So what you're seeing is somebody's driveway in Texas. Why do you care about somebody's driveway in Texas? Because this driveway has the shadow of part of their house that has an edge to it. So why do you care about a driveway in Texas that has the shadow of an edge? Because this person now took many images. They had a webcam that kept taking pictures of this driveway at the same time every day. And so what happens when you do that is you create an analemma. So an analemma is what happens if you look at the sun at the same time every day. You realize the sun isn't returning to the same part of the sky every day. It's returning to a slightly different part at exactly noon, say. It returned when it's noon the next day, oh, it's slightly different. And the noon the next day, it's slightly different. And the sun creates like a figure 8 in the sky. But you have to have a lot of patience to do that, to look at the sun every day. And many days it's cloudy, you don't need it every day. But and so a lot of people go to a lot of trouble to create analemma. But this guy was just taking pictures of his driveway every day with a webcam, and he was able to build up an analemma himself. And I hadn't seen this before, so here you go. It's a pretty short time-lapse video. And here you can see this edge creating a figure 8 in his driveway. And the gaps are when it's too cloudy, but he lives in a part of Texas where it's not always too cloudy. And this is just a great way, and I'm expecting that with this clever ploy, that many people will be sending us their driveway analemmas in the future. So here you can see a visual. This was taken at the same time every day, and I'll run it one more time because it's pretty quick. Same time every day. Here you can see that the sun is not returning to the same, this is looking in the opposite direction of the sun. The shadow of the sun of where it would be was not returning to the same place every day. And the sun moves around during the year. And the sun is going to be at its lowest point in just a couple of weeks when we hit the equinox, no, not the equinox, the solstice, the December solstice in the northern hemisphere called the winter solstice is coming up soon, and it will be the shortest day in terms of, the day is always 24 hours, so it'll be the shortest day of sunlight and the longest night in the year just coming up. So that's another thing. So with that, I will then go to so people keep asking us what's our most popular image. So one of our most popular images this year is just a chance image that was taken by an amateur in Guatemala, I think. And so here you see just a cloud that crossed the moon, and it sort of looks like Saturn's in the Earth's sky. And so this is just an image at the right place at the right time taken by an amateur, and it was just really cool. And so when we posted this as the moon just like Saturn, it's really popular. So with that, let's see. I will conclude. How are we? I think I'm pretty much on time. If you're not now a member of the Orange County Astronomers, if you just joined in to see this, please join the Orange County Astronomers. Here's a link. If you just Google Orange County Astronomers, you can find this link. I will be saying that APOD is celebrated its 29th anniversary just in June 2024. As was mentioned, I have a book out. If you'd like a free copy of the book, here's my email address. If you didn't write it down, that's fine. If you email the Orange County Astronomers, they will show you my email, and you can email me, and I will send you a free hardcover copy of that book. So with that, I will conclude, and let's see if I click again. So I will stop sharing my screen and be really happy to take questions from the crowd. I do see one question there, which I will be addressing in a second. So I have stopped sharing, and now you can see me again.
Wow, what a great presentation. Thank you very much, Robert. I know a lot of us do follow APOD daily, but it's so much fun when you have the commentary on it. Thank you very much for doing this presentation for us. Lovely, lovely. So now let me tell everybody that the floor is open for questions. People online can send them via Q&A, and we will have also taking questions from in person. So let me start by this. I think a lot of people are curious to know how's the daily life in an APOD editor. So do you receive a lot of submissions? Do you do web browsing yourself? How has it changed throughout the years? And what's the scope of it right now? How many do you receive?
Thanks. Yeah, good question. So APOD is generally written by two people. One is me, and one is Jerry Bedell, and we are the founders of APOD back in 1995. We shared an office at NASA Goddard Space Flight Center in Greenbelt, Maryland. And what happened is we saw this World Wide Web growing up, and we were wondering how we can contribute. And one of our lunchtime discussions is we wanted the web to be a smart web and not a stupid web, because we were being sent a lot of pictures just as email attachments, and sometimes the people did not know what it was that they were attaching. So we thought that maybe one thing we can do is we can just try to give just a paragraph of explanation. And so we just started this, and we had 14-page views on our first day, but then it grew pretty quickly and became somewhat popular. So then we realized that it's sort of like buying a dog. Yeah, you got to feed the dog every day, but we enjoy it. There's a lot we enjoy about this. And so this has been going on for 29 years now. And we get about 20 images submitted a day for each one we can run. So there's a lot of good images, which is why now we post some of the really notable images on a Facebook site called Facebook Sky. And there's also a lot of those are cross-posted to an Instagram site called Universe View Screen. So we maybe a few images, 2-3 images a day that were submitted are posted there. We can only run one image a day, and it's not always the most beautiful image. Sometimes it's the most educational image. Sometimes it's something that's very topical. If there's like aurora, or if there's a total solar eclipse, or even a partial eclipse that's interesting, we will run that. Jerry and I work separately generally. We rarely collaborate, other than seeing what the other one is doing and trying not to APOD the same images. So he will do 3 images a week. I will do 3 images a week, and then many times I will then take the extra day, although sometimes he will do it. And that the turnover day is Wednesday. So I will usually be doing Sunday, Monday, Tuesday. And we usually be doing Thursday, Friday, Saturday. And we do email back and forth. There is a change, though, coming to the Astronomy Picture of the Day, because in the next couple of years, Jerry will be retiring. And so currently we have discussions with NASA, a proposal to NASA as to what will then happen. So I hopefully will not be retiring in the very near future, but I'm not a spring chicken either. So eventually I will be retiring myself. But hopefully Jerry will help oversee, and we will have other people who are involved in writing, besides occasional guest posts, for the astronomy picture of the day in the future. And in 20 years, I can't be doing this, and hopefully it will still be a thing, and it will just be run by other people who are as interested and dedicated to it as we are. So I hope that answers most of the question.
So you are still doing them all personally. You do not have students helping you choose images and write this stuff.
So I do have students do things. So sometimes they will find an image and alert me of it. Sometimes they'll do what's called an image chase, so which can be devastating. So someone I saw or they saw a really cool image on the web somewhere or on social media somewhere, but we don't know the real history of that image. We don't know who took the image. We don't know if it's a real image, because there's a lot of AI images out there right now. And that's a long story. I could go on a long story about how AI and APOD are interacting. But if it's a fabrication that doesn't exist, we're probably not going to run it, right? Maybe if it's of an exoplanet, but that's even another long story. But we don't know some of these. For instance, there's one of these recently, one that comes to mind is there's a picture of a volcano on Mars that has a long plume out from it. And so people are sharing this image as if it's an image from Mars Express. But we can't find Mars Express image like that. We can find another Mars Express image like that. So what I do is I turn it over to my students and say, here, go find that. See if you can find it, you know? And so that happens, a few times a month. Here's a cool image. Don't know if it's real. Please see if you can find it. So my students also help keep up social media, because they're much better at social media than me. So some of the images they on, like, for instance, Facebook Sky and Instagram Universe View Screen, some of the images they picked out, some of the images I picked out. And then if some of the images they post there are real popular, then we'll say, oh, okay. And then I will be writing up the image. But in the future, some of the graduate students will be occasionally writing up some of that. And when an image is written up by neither Jerry nor me, we will give a text credit. So we do have guest writers occasionally. Maybe once a month or so, we'll have a guest writer, usually on Wednesdays, and we will identify them. But almost all of them are still written up by either Jerry Bennell or me. That's another long-winded answer to your question.
And also one thing, how's your writing process? Do you do them in batches? Like, do you choose the images for the week and then later on post them, or do you do them daily?
Both. So Jerry usually does his the night before. I usually try to stack mine ahead. So I will try to do much of the week ahead of time. But for instance, so I'm already a little bit ahead. I have 2 stacked up for this coming week, but I don't have the rest of mine, because I know the Geminids meteor shower is here. And so it just happens to be peaking as we're speaking. And so we're going to be expecting a lot of images coming in. So I'm leaving room this week to react to some of these images and then post timely images from that. But many times I will APOD in advance anyway. And then if an unexpected image comes in, I will do what's called a preempt, and I'll just push that image into the next week, and it'll be done a week ahead of time. When Jerry travels, sometimes we will what we call APOD in advance, as much as a week or sometimes 2 weeks in advance. But that's a little bit unusual. Usually we're at most a week in advance, usually a day in advance, and right now waiting on good images on an astronomical event, which this time is the Geminids meteor shower.
And throughout the years that I've been following APOD, I have not seen any days missed. Am I right?
I could go on for years about that. So yes, to the best of our knowledge, we have never missed a day. However, the US government has missed days because they closed due to budget negotiations many years ago. So what would happen is we would then post our image to social media, or we would, at one point when this happened, we declared the United Kingdom site out of University College London to be the flagship site, and that was the first one to update. But then after the budget negotiations were concluded, we just came back and went back to our old, but we've hit every day. Yeah, and sometimes there's a story behind it. Sometimes our technology doesn't work, and then we get emails sometimes late at night, like your technology didn't work, it didn't update. And so then we will try to figure out what went wrong, and sometimes we will update later in the day. So when the first gravitational wave uh, event occurred, we actually held on and we didn't update on purpose until well, it was essentially in midday, which is unusual for us because we wanted to report along with and still observe the embargo on the image on the first gravitational wave event. So it's a long image, long story again. So there's many times stories about many of these that you see, and so they're sometimes interesting, sometimes they're just interesting to us. But I can go on, and these are great questions. But yeah, there is an APOD for every day so far for 29 consecutive years. And there's one scheduled for tomorrow, so there'll be one for tomorrow as well.
Great, thank you. So let's now turn into the in-person audience. Barbara, do you have any questions?
Does anybody have any questions out there? Yes.
I can't hear the question.
She will relay them, I believe.
Okay.
I'm sorry, it was, could you repeat that? The question is exactly what is the book about? And the person that asked the question knows the title much better than I do. But if you could give us an explanation, we would all really appreciate it.
Okay, so the title of the book, actually, I happen to have one a little bit here. I have to move it or else the screen will. So it's called Faster Than Light, How Your Shadow Can Do It, But You Can't. So one of my research topics, so I'm a research scientist. So I've done things on astronomy, gamma ray bursts, clusters of galaxies. I'm a little bit all over the place. But I've always been fascinated with the speed of light, as many people have been. And so it turns out that it's not well known that your shadow can move faster than light. So in my view, humans and anything with mass generally cannot pass you by faster than the speed of light c. So Albert Einstein was really famous for talking about this in with special relativity in 1905. But that doesn't affect laser spots, or it doesn't affect your shadow. It also, there's distant galaxies out in the universe that are moving away from us faster than the local speed of light. There's also quantum mechanic experiments where there seems to be correlations that if you didn't know better, you would say these things are communicating faster than light. But it's not really communication, it's more correlation, not communication. But if you didn't know better, you would think that these two particles were sharing information about their spins, for instance, faster than light. So there's many things that seem to skirt this or get close to faster than light phenomena. So in my book, I try to go through them one after the other and never believe that we and things with mass can go faster than light near us anyway. But there are strange exceptions that appear to break it, and I break them down at a popular level in the book. And so I've actually published a few research papers in this area that are published in research journals. So this stuff isn't just my idle speculation. A lot of this has undergone professional peer review. And it's my hope that some of these things like shadows moving faster than light, which doesn't break any rule of special relativity, law of special relativity, might actually be seen out in the universe when the Rubin telescope starts taking high cadence images of the sky. We might be able to see shadows moving along and flashes moving along things actually at superluminal speeds, which is, again, not against Albert Einstein. He would say, "Oh yeah, that's for sure." So I hope that's a teaser. So, doing well, getting good reviews on Amazon right now, I'll say. So I'm proud of that.
Thank you. Great. So here we have another question about the analemma that you showed. Can the analemma of the Earth perhaps be caused by the Earth's Theia collision that formed the moon?
Okay, so there were very different topics. So the Earth was struck way, way long ago, and in a tremendous collision that caused the moon. So the moon doesn't really have much or anything to do with an analemma. The analemma is to do with the spin of the Earth and the tilt of the Earth as the Earth goes around the sun. So when the Earth goes around the sun with its tilt, the sun, that's what causes the sun to return to different places in the Earth's sky every day. The moon doesn't really have anything to do with the sun returning to its place. There are things called lunar analemmas that are a little bit different, but a solar analemma is really kind of different than what the moon is doing. I hope that's clear enough.
Well, the questioner clarifies more that he was wondering if the tilt of the Earth was caused by that sort of collision that there was.
Is the tilt of the Earth caused by the collision with the moon? I don't think anyone knows the answer to that question. The Earth could have had a pretty tortured past early on and undergone things that might have amazed us today. So I don't think we can clearly point to one event, although it was a hell of an event that created the moon out there, wasn't it? I don't think we can clearly point to that and say, yeah, that one was it.
Okay, great. Thank you, Barbara. Any in-person questions?
Any other questions in here? I don't think I'm seeing any hands raised, so I'll go back. It looks like there are quite a few things on the chat.
Yes, we do still have more questions. So, since you're doing this APOD, one might think you know best what's going on in the astronomy community everywhere.
Not so much.
Yes. So questions about, for example, LIGO. Do you know if there are future plans to have something more precise than LIGO? Everybody has heard here the sound sonification that they've had, but maybe an instrument that can produce images?
Okay, I'm not an expert in LIGO, but I do know there's planned futures to LIGO. That there are space-based, both space-based and better ground-based ways of measuring gravitational radiation that comes across the universe that are in the works. So we can expect in the next 10 years, if these things pan out, that LIGO was just the beginning, and we're going to be able to see more gravitational wave events, which are usually supermassive black holes that are spiraling in, although sometimes they involve neutron stars. And we will be seeing further out in the universe, and we will be seeing different wavelengths. So different wavelengths will be able to tell us different objects that are creating these great gravitational radiations. Also, we're being able to see more changes in pulsars. And so there's collaborations that are looking at pulsars across the sky and beginning to realize that there are correlations between pulsar changes in their very accurately recorded periods that are indicating things having to do with gravitational radiation. And that's going to become much better known in the 10 years. But it's not my subfield of work. But you're right, I do know a bit about it because we report on some things having to do with this on the Astronomy Picture of the Day. Right.
Great. Along those lines, the next question is about the person has heard about a terrestrial planet finder that was going to be launched that could look at the atmospheres of exoplanets and find biosignatures. So do you know if that's still happening?
Okay, so the Euclid mission has launched recently from Europe, so that's partly doing it. But then there's going to be another space telescope that's similar to the Hubble Space Telescope that's going to be launched. I think it's the Roman Space Telescope, Nancy Roman Space Telescope, and I think that's going to have a much wider aperture. So I don't think it's going to be. It's going to be more like a scout rather than the cavalry. It's going to say there's different um, there's different exoplanets out there that appear to have data that might indicate they could have biosignatures with them. And then that would be followed up by either ground-based telescopes on the Earth or by the James Webb Space Telescope or other telescopes. So there is at least the US, Europe just launched one. The US is going to be launching the Roman Space Telescope in a few years. So there are plans, and exoplanets are on the agenda for all of these. And it is a general goal of astronomy and somewhat of NASA to try to find life in the universe, Earth analogs out there. So this is something that is very much on the mind. There are panels, there are many scientists who are studying this and trying to find the best way to go forward.
Thank you. And the next question is about the image on your background. Can you comment on that? What is that?
Okay, so this happens to be a really good background image. This is it's an ARP interacting galaxy. I can move out of the way, but what happens is I think my automatic zoomer is going to move it back right over me. But here you can see the center of this it's two colliding galaxies, and there's this huge ring that goes around, and it's a bright blue ring. So this is one of the from the ARP Atlas, and it's been featured a couple times in the astronomy picture today. I forget the exact number of ARP it is, but it's a colliding galaxy. It's got a lot of star formation in it, and I really like it as a background because it's sort of like a halo around the person speaking, and then you can see, oh, there's something cool going on in the background. So if you email me, I can search for it. You can just go to the APOD search engine or just Google and type UGC for UGC catalog or ARP, and then type site:/apod.nasa.gov and go to images, and then you'll see this is one of those and click on it and it'll tell you lots about it.
Wonderful, thank you. Barbara, any in-person questions?
Anybody thought of another question? Oh, yes, up in the back. Could you give your email to contact you at?
Okay, let's see. Okay, so it's my last name. What's the best way? I can't put it in the chat. If I put it in the chat, could you see it?
Not in person, audience. If it's okay with you, I can publish it on our website, or you might want to share the last slide again.
Okay, I'm going to share the last slide again. There you go. That's a good idea. Okay, so we're going to have to share the whole thing. It's going to take a second for me to do this. Okay, so here we go. Play from current slide. Here we go. Hopefully you can see this. So it's my last name, Nemiroff, at, as you know, MTU stands for Michigan Technological University.edu, which stands short for education. So I think if you were to email one of the officers from the Orange County Astronomers and say that you missed that email address, I think they would be kind enough to send you my email address. And
Sure.
Got too much trouble. And
did you get it? Okay, it looks like people were here copying it down.
Okay.
Okay, any other questions here? Nope. Okay, back to you.
Sure. So let's go back to APOD. How's your relationship with the translators? You said you have 20 more, but one thing I've noticed, actually, maybe I was involved with one of them a little bit. is that the translators are not as consistent as you are. A lot of them appear and then they cannot keep up with the pace, or they change. How's that working on your side, and what's the current status?
Okay, good question. So we don't commission translations. We don't say we want a German translation. What happens is we get email from someone who says we want to do a German translation. And so what we at APOD Central say is, okay. And what happens is we then start following to make sure they're doing a consistent job. And then we put it on our About APOD world languages site. And so we don't have any direct communication with them. What we do for them is we put them all on a Gmail list so they can communicate with each other. And if we have something that's going to be unusual, we communicate with them all that way. And we ask them to contact each other about how they're doing that and how they're creating their own translations, but we don't have daily contact with them. So what happens is some of these translators are very dedicated and do wonderful jobs. Some of them, it's just too much for them. And so they go for a few months or for a few years and then they drop out. And so if they drop out, eventually we will take them off our list. We don't demand that they do it every day, So we think anything, if it's done every few days, even if you missed a week and then you go back and you do it, that's fine. Some of them are beginning to rely more on like Google Translate or GPT Translate, but some of them are not. There's a lot of technical terms. And so we've, every now and then we have a yearly meeting. We're trying to have more meetings where many of the translators all meet together on a big Zoom call. And then we talk about things that are common problems. That's somewhat unusual. We had one maybe a year ago on that. And we found out that some people have unusual problems. For instance, some like in Taiwanese, there's just fewer words for astronomical terms than there are in many other languages. So the woman who's doing that creates her own words. And so she really puts a lot of effort into this. So we're just really happy that she does this. But the answer is we have what we call as a volunteer army. Volunteer armies do the world language translations, and many of them do the social media sites too. And so every now and then we check and see whether they're still active. If they're not active, we'll maybe they had a bad time. We'll email them and say, do you still want to be? And then if not, we'll just take them off. But many times then new ones are coming on. And so there's a continual change of those. So we have about 20 right now, world language sites. And we have many social media sites that come and go too. Some social media sites are in world languages. So there's a Portuguese Instagram site. We didn't commission it. We love it, though. We think it's great.
So you do not send the stuff to them beforehand, right? They just get it.
We tell them where to get it. So some of the APODs are generally available before they appear. So the mirror site operators and the world language translators know where to go find it. But sometimes, particularly when Jerry does it, they're only available for a few hours before they appear on the NASA site. So, but that few hours can be useful for them too. But yeah, they're part of the volunteer army. So we're so tickled to have people who care about our site so much that they want to translate it into other venues. So we think it's great. But so we support them, but we don't control them.
So back in the day in 1995, when you started, I would imagine it would have been much harder to come across a good image every day. But nowadays, it's like an explosion, right? It's very hard, I guess, to choose which one to do, as you mentioned also. So what's your policy on repeats, since you mentioned there are a couple of images that have been repeated several times?
Yes. Okay. Good question. So early on, we were worried as we were coming up with we were formulating the whole APOD idea. We were worried that we would run out of images. And then what would we do? But a sort of a backstop for that is we realized that the Ranger mission NASA's Ranger mission to the moon took hundreds of thousands of images of the lunar surface. So the worry was really that APOD would become boring, not that it would repeat. So we could just show, oh yeah, you haven't seen this crater yet, have you? See, the lip's a little kind of different over there, isn't it? But it would get kind of boring that way. But to our surprise, there's just so many good images out there. And we used to have to go around and go to the major observatory sites and communicate with David Malin and see what he's up to. But now we do still look at the major sites, and we see on social media many things are posted, but we just get sent so many good images that we just have to reject. It's a shame too. It's such a shame that so many great images are sent to us that we just can't run. You know, if we get sent 20 good images today, we can run at most one that day. So we do repeats though, because a couple reasons. One is that some of the greatest images of all time uh, are not seen by the most recent viewers of APOD. So APOD's viewership turns over. So many people have only been with us a few months, a year, or something like that. They didn't see the greatest images of the 2000s. Should they never see them? No, we think they should. So on weekends, typically, we will run repeats. Not always, but we will run repeats. And these will be the greatest images of APOD of all time to expose the new viewers of this. But that's only one of the reasons. Another reason is to lighten our load, because it's easier for us to run a repeat. And it's not completely a repeat because we update the text with modern things that are known. We update the links because some of the links have gone dormant. And so we'll refresh the links. So it's just less work, not no work to do that. But yes, many times, Saturday, Sunday, and on rare occasions, other days, we will run repeats. And we think there's good reason for that.
And about the website itself, so you have changed the URL now. You have years back you got it off. Before it was like a slash NASA something. Now you have apod.nasa, and I don't know about the back end, but the front end hasn't changed much during the years. What are the plans for that? Do you want to keep it that way? And how's the background? How's the backbone operation? Does that have a dedicated server? How does that work?
So we grew up, Jerry and I were at NASA Goddard Space Flight Center. So we have a small group of people there who have supported APOD always from Goddard Space Flight Center, and they are just great. So for instance, we now have 4 virtual machines that APOD is served from. Originally, it was the hard machine on my desk. It was right there. I could point to it. There it is. That's where APOD comes from. And then it was a couple machines, and then it was some blade machines that were down the hall. And then it was another building at Goddard. Now, I don't know. Now, this might be another building at Goddard. I don't even know where it is. But they're virtual machines now. You can't point to a machine. These aren't real machines. I can tell you stories. Okay, so anyway, these machines are created by the great background folks at NASA Goddard Space Flight Center. But NASA has something called the web modernization. So there is discussion on both sides as to whether APOD will be able to stay where it is at apod.nasa.gov, or whether in the near future, APOD will be asked to move to science.nasa.gov/APOD. And right now, it's a matter of discussion that hasn't, in my mind, been completely settled. So I don't have a definitive answer to that. But to my knowledge, there is no movement to get rid of the astronomy picture today. We're happy being at NASA. NASA is happy with us, so it will continue. And at least for the foreseeable future, meaning months, maybe a year, it will be from apod.nasa.gov. And that's all you need. You don't need to know the /apod like you had in there before. You just get there by apod.nasa.gov. And even in the future, if we move to science.nasa.gov/apod, you can go to apod.nasa.gov and it will then push you over there. So that was, again, too many words, but that's the long story.
And also, could you comment on the like the interface? You haven't changed the appearance of the website for.
Okay. Yeah. Okay. Yeah. Okay. So another I could go on for a long time. So the way I see it, it's our appearance was sort of set in 1995, a little bit toward 1996, because when we first started APOD in 1995, there was no center tag. So all the APODs were off on one side and they were ragged right. But then they came out with the center tags. We said, okay, yeah, you're right, looks a lot better centered. So since then, we've pretty much kept the same design. So the way I look at it, it's a little bit like the Volkswagen Bug. Kind of works. Doesn't have to be really fancy. Doesn't have to be updated every year. So, however, so every year or so, a couple of months, people email us that they're going to redesign us. So eventually, which is fine, but I don't know, we don't really feel a great need to be redesigned because essentially we're sort of proud of our old time. It sort of says, yeah, we've been around for a while. Sort of a badge of pride at this point. Still, as part of NASA's web modernization, it looks like we will probably be updated to look like a lot of the NASA websites do. And so even if we stay at apod.nasa.gov, which we don't know, even that we will probably look a little bit different on the time scale of a year or more. And we will look a lot more like the standard NASA websites. So we've been holding off on it for a while, but we always knew we'd be updated. So that's coming soon to APOD is a slightly new look.
Okay, great. Thank you. Barbara, any in-person questions?
No, but I'm told that the snack shop has to close down and we need to start cleaning up here. I think that we may have students coming in soon. I'm not sure what the schedule is.
Sure. Let me ask the final questions and then we could all go home. The questioner wants to know, have you featured any images generated by the alpha magnetic spectrometer on the ISS in APOD?
I don't know. I'm going to find out right now.
Does your search, I think it doesn't, but does your search work by searching for the photographer or the thing?
Yes, it can work.
It does. Okay.
So in 2014, we had something called Space Station Detector Finds Unexplained Positron Excess. And that talked about the lead title there was, where did all the high energy positrons come from? The alpha magnetic spectrometer, AMSO2, on board the International Space Station has been meticulously recording how often it is struck by both high energy electrons and positrons since 2011. So we have a picture of the AMS device there. And we discussed some of the science from it. So I think the answer is yes. We have a picture of the AMS spectrometer, and it appeared on APOD, and I forgot the day, on October 6, 2014. So you can find it there.
Wonderful, thanks. And the final question. Yes, you wanted to say something?
I just want to thank the Orange County Astronomers for inviting me, and to you, Reza. This was a lot of fun, a very knowledgeable audience, and so thank you so much for having me on. I really enjoyed being here.
Sure, thank you very much. But there's just one question left before ending this, and the person wants to know about neutrino detectors. Do you know if there are any plans to be sent into space, or what's the current status on them?
Neutrino detectors. Let me think. I think there are neutrino detectors. I know there's Kamiokande. I think that's still running. I'm at a lack for details, but my understanding is, oh yeah, okay, that's right. There's one in the Homestake mine in South Dakota, I think, that's recording neutrinos that are being sent by Fermilab. But besides that, it I think is pretty sensitive and can see neutrinos if there was a supernova explosion close enough to us, like 1987A was. It could see the neutrinos from that detector. And I think that there are more and better neutrino detectors being planned, but I wasn't in the future, but I don't have specifics on that right now. But neutrino astronomy, yes, is a very interesting part of astronomy. And neutrinos do make up a small fraction of the mass energy of the universe.
Wonderful. So thank you very much, Robert, for accepting my invitation and doing this presentation for us. It was very lovely. Thank you very much. And I hope you see the kudos that's coming your way online. So I would also like to thank our audience, both in person and online, for joining us. And I hope you join us for our future meetings as well. You could find all the information at ocastronomers.org. With this, I wish everybody a great night and bye-bye.
Bye.